In software engineering, the development of a new feature follows a defined sequence of stages known as the feature lifecycle. This lifecycle ensures that every feature is systematically conceived, designed, implemented, tested, deployed, maintained, and eventually retired when it is no longer required. Each phase plays a critical role in ensuring that the feature aligns with business goals, meets user needs, and maintains technical integrity within the broader system. This chapter provides a detailed overview of each phase of the feature lifecycle, illustrating the importance of a structured and iterative approach to feature development. Phases of the feature lifecycle. Idea/concept. The lifecycle begins with the generation of a new idea. Ideas may originate from customers, stakeholders, market research, internal teams, or competitive analysis. At this stage, the concept is typically broad and not yet technically defined. It is captured and recorded for further exploration using tools such as Jira, Trello, or other product management platforms. Requirement gathering. Once an idea is prioritized, business analysts and product managers work to gather detailed requirements. This involves engaging with stakeholders to define the business problem or opportunity, the target users, and the desired outcomes. The output of this phase often includes user stories, use cases, acceptance criteria, and sometimes early prototypes or mockups. Design. In the design phase, the solution is architected both visually and technically. UX/UI designers create wireframes, workflows, and visual mockups. System architects define the software and infrastructure architecture, including databases, services, and APIs. Developers may create technical design documents outlining the technologies, frameworks, and integration points to be used. In some cases, a proof of concept or POC is developed to explore technical risks. Development. Following design approval, the development phase begins. Developers write and integrate the code according to the specified requirements. Best practices such as version control, for example, Git, branching strategies, and peer code reviews are employed to maintain code quality. This phase often overlaps with unit testing and continuous integration practices to ensure early detection of issues. Testing. Testing is critical to validate the functionality, reliability, and performance of the feature. Common testing activities include unit testing, which is testing individual components, integration testing, testing interactions between components, system testing, testing the feature within the entire system, and user acceptance testing, or UAT, which involves testing by end users or business representatives to verify the feature meets expectations. Defects found during testing are logged, prioritized, and resolved before proceeding. Once testing is successfully completed, the feature is deployed to a live production environment. Deployment strategies may include canary releases, which involve rolling out the feature to a small group of users initially, feature toggles, which control feature visibility until ready, and blue-green deployments aimed at reducing downtime and risk during rollout. Automation through continuous integration and continuous deployment pipelines is common to improve speed and reliability. After release, teams actively monitor the feature's performance and usage. Monitoring tools such as Datadog, New Relic, or Google Analytics are used to observe user engagement metrics, system performance, and error rates. Feedback from users, customer support, and internal stakeholders is gathered to identify any further enhancements or necessary fixes. The maintenance phase involves ongoing support for the feature. This includes addressing bugs and technical issues, improving performance, making incremental enhancements based on user feedback, and ensuring compatibility with evolving platforms, devices, and regulations. Proactive maintenance ensures the feature remains valuable and effective over time. Eventually, a feature may become obsolete due to changing business needs, user preferences, or technological advancements. In the retirement phase, users are notified of the upcoming deprecation. Data migration or alternative solutions are provided if necessary. The feature is removed from the system in a controlled manner to minimize disruption. Proper retirement planning helps maintain a clean, efficient, and user-friendly product. The feature lifecycle represents a disciplined framework for managing the creation and evolution of software features. By progressing through a series of structured stages, from ideation and requirements gathering through to retirement, organizations can deliver reliable, user-centric, and maintainable software solutions. Understanding and applying each stage of the feature lifecycle is fundamental to successful software engineering practice and supports long-term product sustainability and user satisfaction.